Hey yo, welcome to stream everyone. So as usual, uh, we're now streaming. The stream is good actually. So another day, another video. This is Code Raw, and as usual, we're gonna solve some lead code problems. Today we're gonna solve the lead code problems about linked list. Uh, and the theme. So for the new followers. Thank you for following, by the way. Every video is talking about theme. Today theme is the time loops and twin bonds. We're gonna try to solve actually two problems of the linked list. It's a very interesting data structure. So the first problem will be the linked list cycle. Which is titled Scott in a time loop. So protagonist is trapped in repeating time cycle and must find the way out. And the second problem will be the maximum twin sum of linked list, and it's gonna talk about twin bond power. So twin heroes unite their strength to overcome a formidable challenge. Welcome everyone. Bring anything you can drink and enjoy the stream. So those are my social media account. You can follow me on GitHub. You can follow me also on Instagram or on LinkedIn. And recently we made a Discord server that you are free to join it every time you want. And without further ado, let's go to the lead code problem. So the first will be the linked list cycle. Okay, so let's delete that. And let's pop this. Okay. So everything is good. Okay, let's go. So, given a head, the head of linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tells next pointer is connected, to note that pos is not passed as a parameter. So return true if there is a cycle and the linked list, otherwise return false. So those are the example. This is a linked list. The head of this linked list is 3. The linked list will continue until -4. It's gonna go back to the 2. So the head equal this, position equal 1, and true. So pos is not a parameter. Okay. So that will equal true. Okay, and so it is, if it's only one node, then it will return -1, return false. So let's go. Okay, why the input is not, he said that the input is not a parameter. Pos is used to denote the index of the node that is still. But what do we need this for? Let's begin. That's no problem. So the thing, or the design pattern that we're gonna learn today, we actually did it yesterday, which is the fast and the slow pointer in linked list. So I think we can work on it like that. Let's see, we have this 3, 2, 0, and -4. Okay. Excuse my bad writing, and then we return to the 2. So I think the obvious thing that we're gonna make a pointer, and then we're gonna iterate through the linked list one by one, like that. And then if there is no next node, then it is a loop, and for that we're gonna return true. Okay, just like that. So gonna iterate through the linked list, and if there is no or if if there is no next or current dot next return none, then there is a loop, and for that we're gonna return true because there is a loop. Okay, that seems cool. Okay, so we're gonna make this and then this. Oh, okay, but with that approach it will be a infinite while loop. The while loop will not stop. Okay, let's think. Okay, let's use the fast and slow pointers. So now let's make okay, so okay, num okay. So we're gonna name this a fast. So this fast will iterate through 2 nodes at a time. So the first 3, the second is 0, and then we'll go to that, which is the -4 is linked to the 2. So it's gonna go to the 2, and then we'll go to the -4, and he'll repeat that iteration. Okay, and the slow let's call it slow, will go a node by node. Crypto bro, you got it. Hey, thank you man, welcome stream by the way. We'll go one by one until it meets with okay, what the condition? Oh, until it meets with the fast pointer. So we have to guarantee it meets. So in that iteration -4, and then and this will be -4, this will be -2, that will be in 0, and then -4, that will be in 0, and then -2, that will be in 4. Yeah, I think they will meet. Okay, let's start with it. So let's get that away. Don't need that anymore. And yeah, all good. So we'll have, like we said, 2 pointers, which are fast and slow. We'll start the 2 from the head, and then while fast next while fast and fast next think fast and fast dot next. Or slow. Okay, we're gonna deal with that later. So if there's no current next, so after this loop, if there is no current next, then he'll return true. So it's gonna return true. Oh. So that so now current will be or fast. So now fast will be fast dot next will be 2 times, and slow will be slow dot next. If the slow equal the fast, can I make it like this? Then there is a loop. Okay, so true. So I think it's gonna return true. So I think here it's false. False. So if he reaches a non-loop, so it's gonna return false because there is no loop. Okay, we're good. I think we're good. Let's just submit it and see. Okay, don't trust. Oh, it's right from the beginning. Oh, I hope it's right. I hope it's right. Okay, let's go. So the solution is right from the first try. That's good. Yeah, I revised the linked list, so we're good. Okay, we're good. A good beginning. So without further ado, let's go to the second problem. Okay, so now we have the maximum twin sum of a linked list in a linked list size of n, where n is even. So it is even. It is always even. Okay. The ith node, 0 indexed, of the linked list is known as the twin of the n minus 1 minus I node. Okay, so n, the ith node, n minus 1 minus I. Okay, so this is 1, this is 4, minus I minus 1. Okay, 2. If 0, for example, if n equal 4, then node 0 is the twin of the node 3. Huh? So 3 minus I. No. The node 0 is the twin, node 1 is the twin of node 2. Okay, 1. Node 2 and 0 is okay. There are only node twins for n equal 4. The twin sum is defined as the sum of a node at its twin. So given the head of a linked list with even length, return the maximum twin sum. Okay. So head. Okay. Node 0. No. Let's see. Let's put it like this, and it's like that. Okay, so we're good with this problem, so let's go to this. Okay, so like we see, we have this linked list. This is 5, 4, 2, and 1. Everyone is related to another, and they are 0 and except. Okay, so 0, 1, 2, and 3. Now we're gonna sum. So those are twin. Okay, I'm gonna sum them. So the sum is 6, and here the sum also is 6. So max equal 6. Okay, and then okay, how are we gonna do it? I'm gonna use the fast and the slow pointers to do this. So those two. Okay, let's initialize them first. So we're gonna initialize fast, and this is slow. How are we gonna do this? So one will go. والله اللايت ما هو شيء اخويا بريكل. والله منقص اللايت تذويب، والله منقص ولا. مرحبا يا اخويا، مرحبا بك. اوكي، نقص شوية نورمالمون تو سافا. والله مش برشا لايت. اي جي انا ريكشين لينكد ليست توزع بالك شوية. امم عايشة كذب. ميرسي، يعطيك صح. ثانك يو، ويلكم. So I'm gonna do it using two pointers which are fast and slow. So the first idea, the first will go from this to what? To this? No, it can't be. It cannot be. Or should we do it with only one pointer? I think the one. Okay, let's see with one pointer. No. Hey, hello, man. Welcome to stream. Hey, chat, you can type this command to see the server Discord link. So, as you see, the chatbot will send you the link. So, I'm gonna ping it. So, type Discord. You can type Discord. Hey, fine. How are you? How's your day, man? Really good. We're just solving some read code problems about linked list. This problem is pretty good actually. I don't really know how I'm gonna do it, but okay. So the third example, we're just gonna sum the two if there is only two, which is 1 and 100,000. We're just gonna sum it using one pointer. We're gonna sum this and return it. Okay, so if I said if first dot next equal none, so there is only two nodes, then we're gonna sum the two and return them. Okay, thank you. Okay, so this is the first approach, and then I think so this is okay. This is 5. This is 9. This is this is 11. This is 13. So we're gonna okay. This problem is I'm gonna use this test case. Okay. So I'm gonna use this. I think the problem is pretty hard. It's not the fast. It's not that easy actually. So 2, 2, and we have 3. The sum will be, the max sum will be 7. So max equal 7. And the idea will be that we sum those two. We're gonna sum those two. And well, I think we can make a but for that it will be, and then deleting or oh, or I think we can initialize n, which is the length of a linked list. Well, the first iteration, okay, so the first iteration will be, okay, I think I have the idea. So we're gonna make a while loop. While I think I'm gonna use only one pointer. Oh, only one pointer, not two. So while let's say current dot next I'm gonna sum only the first one. How I'm gonna say it? Okay, so we'll have a variable or like max sum. So max sum or sum equal first dot value. Just here. Okay, so the idea will be that I'm gonna sum this. I'm gonna sum this with this, and then I'm gonna delete this, and then iterate another time, and not from this index, but from this, and then sum it, and then delete it. And if it's if it's n minus n divided by 2, if we reach n divided by 2, then we're gonna stop, because that is the length of the linked list. So like that we're all okay. So for that I think I need 2 pointers. Okay, so 2 pointers. One will be in this start. Okay, so we'll name 2 variables, 2 pointers. One is start, and the second start, and the second will be the end. So in every linked list, we're gonna iterate through every one of it using start and end. So I'll make start with a the start, and this is the end. Okay, the end will start here also. Okay. First thing, but for that it will be okay. I think I'm gonna return the length of the linked list. Okay. And then we have to iterate the end till the end of the list, and then sum this 2 up. Okay. Or we can simply, there is no dot brief. We cannot go. Cannot go to the previous one. Okay. So we're gonna sum those 2 and make it in a variable. We'll name it max sum, and then we're gonna delete this, or we're gonna just make this pointer point to none. Or I think we don't even need that. And then we're gonna iterate again. I'm gonna iterate again, but this time we have to move the start and move the end until the start is pointing at the end. So with that, we're gonna make the last sum, and we're gonna return it. Okay, so let's begin. So start equal head, start and head equal head. I think it's a little bit complicated, but it can work. So I'm gonna make size equal 0. And I'm gonna make equal head and while count dot next count equal count dot next and size plus equal 1. Okay, and now size would be equal to 0, and after this while the size will be the length of count equal next plus 1 and plus 1. No, so let's do this plus 1, let's do this plus 1. So I think this has to be here, and now we just I'm gonna print the size. And why it is not responsive. Okay, so the size is 3, so the size will be initialized to 1. Initialized to 1, so print size, and then the start will have the first, and the head will move until it's next. So while head dot next while head dot next, and I think while head while end will be end dot next, and we have the increment start. How are you gonna increment start? It's an even, so this dot next will be this, and this will be 1. So if we're gonna use the fast and the slow, so this will be here and then will be here, and this will be there and then will be there. Yeah, and what? I really don't see it. So I'll be this So for I'm gonna make a for loop. I'm gonna make a for loop. So 0, 1, in first iteration the start will, we're gonna just sum the start and I'm gonna sum equals start dot value plus end dot value, but we don't have the end of value, so I'm gonna make it after. So this one end, oh no, so after this, okay, so oh, this is for the size. So print size for G in range n while end. Okay, so the end now is in 3. So we're gonna sum, which is the start value plus, okay, and then we're gonna return if sum is greater than max sum, then max sum will have sum. I'm not gonna make it sum, I'm gonna make it sum 1. But I think here it's while end. So while end is not none, and end, so while none. Okay. Sum equals start value, and then we have to increment the value of start. We're gonna sum and then increment the end of start. So sum start equal start dot next. I think that should go. Okay. Size. Float. Okay, so size equal size. So same thing. It is a float. Okay, I'm gonna make it int. I'm gonna print size. How you cracked some job? Oh, so I didn't do yet because I'm really a student. There is a lot to do these days, but I hope in the next month I'm gonna do some research about the internships. I hope I get one. So, and, welcome to stream, by the way. Value. Dot value. And dot value. Yes. Start and end. I'm gonna make some equal to 0. So why this is not working? Itself. Okay. So the problem is in and. Also, we have to return maximum. Yo, chat. Whip up. Yeah. I hope it's good. I hope it's good. I hope it's good. I hope it's good. Oh man. Okay, so what's going on? So the logic here is good, but so 17. Okay. 74. Output is 1. Let it be 182. This case is cannot even. So I'm gonna here. I'm gonna print the end every time. So I think I'm gonna print here. I'm gonna print the start val and the end val. To make it clear. So let's get rid of that and let's just submit it. I can use this SK, so I'm gonna run it. So okay, so oh, why is it? Hmm. We have to stop end. So I'm gonna stop end. So while end next, and then I'm gonna point end dot next equal none. To 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 make it. No, it's not. So I have to stop the end the first time at 9, the second time at 5. What languages do you speak? I speak Arabic native, I speak English fluently, I think, and I speak French for sure because I am Tunisian, and yeah, we're very close to the French people, so I think I also speak French. Yeah. Welcome stream, by the way. So the first time we have to stop. So I think I'm gonna make a for loop. So for so for e in range we're gonna start. So first time range I wanted to in range n 0. I want it to be this and then this. So n or size, int size, int size -1. Yeah. Size So let's check for the 17. Why is there 17? 22? Oh, 70, 47, 22 until it reaches 41. Like this. I need to. Okay, so let's run it. Okay, so why it is always 47? Oh, it is. Yeah, no. So for any range, the first time the node has to visit 9, then 5. So it will. So, okay, I'm gonna read this. So for any range. Input. Okay, -1. I'm gonna make it -1. -2. The while loop is not working. So try it in so while end dot next. I'm gonna try the classic way. So the classic way, why it is working right here. So 5, oh it is 6 here, okay. And then 5 3 2 3. Oh, so this is, oh, okay. Yeah, I see. So the pointer is now here, and then okay, so I'm gonna initialize it first thing. No, cannot. And then every time I'm gonna how's that? Why the for loop is not working? For any range n -1. Okay, so I'm gonna test a thing. So for in range 8, okay. Okay, we're gonna test 2. I'm gonna test 2 for 2 times. So why when I use for this cannot work? Okay, I'm gonna just, it's about time, so I'm gonna ask, there is only one thing in this while loop, so I'm gonna ask him. So okay. So there shows code read the while loop inside for loop. No problem. So the goal is to find maximum while end dot next inside the for loop in every iteration. So the logic behind the end pointer need to track the mirrored node. Okay. Okay. Fix. Simplify. So while I wanted to do it my way. Oh, okay. No. No. Okay, I'm gonna. So and size. So while count, we're gonna count it for any. So end will be end dot next. Okay. And then for G, some. So just is that even does that even work? No, it doesn't. No, for sure it doesn't. So the 5421. Okay. So it is 21. We have just to reverse that thing. So 52. Okay. How are we gonna do it? So the end is pointing. Is he? Hmm. No. No. That's not good. So we're gonna learn his way. So why this work? So value current equal head, while current value append. I'm gonna append in a list and then no. I don't need this. So fast and slow. So while fast and while slow dot next, fast dot next dot next. Previous and current none, and the current is slow. So we're gonna reverse. So I need the reverse. I thought of it. I thought about it. Yeah, I didn't give you. I thought about reversing the list, but I'm not the I'm not the ready for it. So he simply reversed the first part of the list. So to clarify the things, he reversed that. So the 2 is pointing now at 4, and yeah, and then he iterated fast from this way and the slow from the way, or the current and the prev, and then he just sum it. So first and second, he summoned the first and second, and he is iterating traversal, which is the traversal reverse linked list. I wasn't ready for that, but yeah, it is a working. This is very depressing. So in the problem we don't need the actual linked list, but we need to reverse it. So this lesson, we understood the lesson from this problem. So it is nearly 1 hour. I think here we're gonna end our stream. Thank you everyone for watching. Thank you everyone for following. Your help is really means a lot for me. I'm really grateful for your help, for your comment. Don't forget to follow me on my GitHub, on LinkedIn, on any social media account. Thank you everyone, and see you tomorrow.